Find the inverse of the functions. All right, so if you wanted to find the inverse of this function, we can basically follow a simple procedure which I've outlined here, which is basically switch x and y and then solve for y. And that works every time, but it's not very insightful. So I just want to show you one little kind of simple idea which I covered in one of the other videos, which is simply that you can undo what's being done to x to get the inverse as well. So if you think about how you would build up f of x, if I had x and I wanted to create f of x and I followed order of operations, so I did everything in the proper order, I would do what? I would maybe multiply by 6 first. So my first step would be to multiply by 6, and then I would do what? Add 1, correct? That'd be my second step. So following order of operations, right? For example, if I wanted to plug a value in for x, I would first multiply by 6 and then add 1. So if you wanted to do the inverse of that, then basically your steps would reverse, right? So you basically say that instead of adding 1, you would subtract 1. And again, we go backwards. So we start from this one and go to that one. So we do minus 1. And then the opposite of multiplying x would be to say what? Divide by something. In this case, divide by 6 because we multiplied by 6 before. All right, and so that's basically how you would be able to do the inverse. And that would mean that you'd start with your x and you would do what? First step, subtract 1. And then second step, divide by 6. And that should be the inverse. That should be f of x inverse. Now, to prove that or to show that, we could do the fog and the goff. In other words, to show that if you do the composite functions, they give you x. You could also show it by performing what I described here, right, in this third kind of bullet point, which is to find an inverse, switch x and y, and solve for y. So let's go ahead and do that and see what happens. All right, so let's see if we get the same answer I got before. All right, so first we're going to make f of x into y. So I haven't done anything here other than to do what? Just make f of x y, which is pretty standard kind of notational switch, which we do all the time actually, right? And then from there, we're going to actually swap these two positions, right? So it'll be x is equal to 6y plus 1, and then we solve for y, right? So solve for y. So a really simple idea. Basically switch the x and y variables and then solve for the y. Okay, so to solve for y then we're going to do what? We're going to take x equals 6y plus 1. We're going to subtract 1 from both sides, giving us x minus 1 is equal to 6y, and then we'll divide by 6. And so we end up getting this statement that y is equal to x minus 1 over 6, or in other words, f inverse of x is equal to x minus 1 over 6. And that's it. Now, a little quick mention here about the domain and the range. The original function, its domain and range, both of them, right, were all real numbers. In other words, you could put anything you wanted into the function. There were no restrictions because there were no fractions, no radicals, etc., right? And the range would also be all real numbers because you can get any negative number or any positive number out of the function. It's just the graph of a line. So likewise, it's the same thing for this inverse function. Remember, we would just switch the domain and range to find the domain and range for the inverse. But of course, since the domain and range are both negative infinity to positive infinity, it's just exactly the same thing for f inverse. All right, let's take a look at the b part then. For the b part, it looks like it's a parabola that's been shifted up 4 units, right? If we look at this, it looks like they moved a basic parabola up 4 units. So they're doing that, but they're being careful to say x must be greater than or equal to 0 because a parabola is not a one-to-one function because it fails the horizontal line test. So what they're actually doing is they're just taking it from this point over, and they're using that piece of the parabola. So if I wanted to find the inverse, again, we can use the formal method, but I would like to actually kind of use that little idea we talked about before, which is what's being done to x. Well, first step we would do to make f of x would be, we'd take what? So for example, if I plugged a number in for x, if I put the number 2 in for x, I would do what? I'd first square it, right? So I'd square, and then after I was done squaring the number I put in for x, my second step would be to what? Add 4, right? So if I want to find the inverse, I've got to do things from here, starting with the inverse, right? So starting with the last step, we'll do that as our inverse. So instead of adding 4, I would subtract 4, right? And for step 2, instead of squaring, I will square root because that's the inverse, right? Okay, so basically what I'm saying is that if you had x, you should subtract 4 and then take the square root. And that should be our inverse function. That should be f of x inverse. But let's confirm that by using our procedure, right? So remember what our procedure is. For our procedure, we're going to replace f of x with y. And we'll set that equal to x squared plus 4. And then we're going to swap the x and the y positions. So we'll have x is equal to y squared plus 4. And then we solve for y. So subtract 4 from both sides. So we'll have x minus 4 is equal to y squared. And then we want to take the square root of both sides. So we'd end up having what? The square root of x minus 4 plus or minus is equal to y. Now, here's the only question about this plus or minus thing. Do I really need to worry about that part of it? I do the plus or minus because I want to make sure that I didn't initially have something that was negative that I squared, which then appeared positive after squaring it, but really it started out being something negative. So what I'm getting at here is, do we really have to worry about that? In other words, would there ever be a scenario where what we squared here when we did x squared originally, could that ever have been negative? I don't think so, because remember that we're only dealing with x being greater than or equal to 0, so we don't allow any negative x values. So we take the square root of x squared, or for that matter, the square root of y squared, because remember we just switched x and y, and that's how we got the y squared that we took the square root of a minute ago. Well, in either case, the numbers going in for this value are always strictly non-negative, right? So in other words, they're either 0 or positive, and that means that we don't have to worry about the situation where we have the negative case. So we can ignore the plus or minus that we normally have to put and just leave it as a positive. All right, so regardless of that, if we know that it's going to be y is equal to the square root of x minus 4, then we know that f inverse is x minus 4, which is what we said it should be, right? Because remember, we would subtract 4 from x and then take the square root, and that's how you'd find the inverse. Now, just to discuss the domain and range very briefly, for this function above, we talked about the fact that the domain has been restricted to be x being greater than or equal to 0. That means that it'll go from 0 to infinity for f of x, right? And the range, I think we kind of discussed very briefly with the graph, but we could also do it another way. If you put 0 in for x squared from the domain, you would get 0, and then you'd add the 4 to get plus 4, right? So in other words, the minimum value you're going to get here is 4, and it should go up to positive infinity from there. And you can see that from the graph, as we talked about before. 1, 2, 3, 4. This parabola was opening up like this. So it looks like the y values will be from 4 up, 4 to infinity. So the domain and range, as we have written on the paper, is correct for f of x. That means that f inverse of x has the opposite then. If you want to know its domain and range, you simply would say that they switch, right? So it'll be from 4 to infinity for the domain, and it'll be from 0 to infinity for the range.